process which is used in preparation of ethanol commercially. So if you want fermentation, if you want ethanol in large quantity, all you need to do is you take out the process of fermentation. Fermentation is simply the breaking down of large molecules into smaller molecules. So that whole process which is involved when large molecules are broken down into smaller molecules by microorganisms is referred to as fermentation. So an example of a large molecule is starch. So when you break starch down to form ethanol, this process involved from here to here is referred to as fermentation. So the microorganism that is mostly used or widely used for this fermentation process is referred to as yeast. So when yeast is added to starch, which is a very large molecule, it will break it down to a very small molecule, such as ethanol. Now let's look at the equations, chemical equations involved in this process. Now the first thing you do is you look for a starchy food, such as rice, millets, wheat. So any of this will do. So all you need to do there is you have to extract the starch out of these carbohydrate products. So you can parboil the rice to get your starchy part of the food out. Then after that, you will now have to add malt. Now malt is what we refer to as a partially germinated barley. So when this plant barley is being cultivated, when it gets to a certain stage, it is used or referred to as malt, and that is the first thing you add to your starch, which you've gotten from your rice or any other carbohydrate products, in order to carry out the process of fermentation. So now, you take your starch. The chemical formula for starch is your C6H10O5. Now, this N here refers to millions of this single molecule, or this formula we are seeing here. So that's why we refer to starch as a very large molecule, because you have millions of these little molecules coming together to form a large molecule. So in order to break this starch down to a smaller molecule, you need to carry out fermentation. So the first process now, step 1, you take your starch and you add a little water. So we add H2O and molecules of it. Then the next thing we'll do is we'll take the malt, which is a partially germinated barley plant. You add it. So what the malt does is this. The malt converts the starch into a disaccharide. And what is the disaccharide? A 2-molecule sugar. So we have something like C12, H22O11. Now, if you balance the equation to see how this comes about, you find out that the H here is added to this H, which has 10 atoms. These 2 atoms of it. So when these 2 adds to this, you have 12. You have 12. So the 2 times the 12 will now give us what we are having here. So that's what we are having here. Then for the 6, you have 2 times 6, giving us 12. So you have your carbon 12. Then that goes along to for the oxygen. 2 times 5, 10, plus the 1, we have 11. So this is the first stage. Starch is converted to what? Maltose. Now your maltose is a disaccharide. It has 2 molecules of sugar. So when 2 monosaccharide combines, it gives us disaccharide. And a good example of a disaccharide is a maltose. Now the next thing to do in order to finish the fermentation process, you now take this maltose, that is your C12, H22O11. Take this, you add a little water too, in order for the reaction to be fast as possible. Then you bring in your microorganism, like we said earlier. So yeast is a microorganism that has so many enzymes. Among the enzymes are zymase, diastase, but those of all the enzymes, those 2 is what is needed in order to complete this process. So immediately you have your disaccharide, that is your maltose. you now add your yeast. So when yeast is added, yeast will release an enzyme called diastase. Release an enzyme called diastase. No, not diastase. Release an enzyme called maltase. Just a little back to what we had the first. The malt releases an enzyme. The enzyme the malt releases is called diastase. So the diastase is what converts the starch to maltose. Then the yeast, which is the next process, stage 2, is going to convert the diastase to the maltose into a monosaccharide. And the name of that monosaccharide is your glucose. And it's represented as C6H12O6. So this is your glucose. So we have 2 molecules of it. So the maltase from yeast, which is an enzyme, converts the maltose to glucose. So this is your glucose. The next step, which is step 3, okay, let's do that up here. Step 3. So the stage 3 or step 3 is where the glucose C6H12O6 is now converted to a very small molecule such as ethanol. So there we have your yeast again releasing zymase. So this zymase is still an enzyme which acts on your glucose to give you 2 products, ethanol as a C2H5OH and carbon dioxide, which is the gas. So this will be given off as a byproduct. So the zymase is what converts the glucose finally to ethanol, the product you are looking for. Now this process is a commercial process of producing ethanol because you have a lot of this being produced. So if the zymase converts this, we can see that the equation is balanced. So let's try balancing it. We have 2 here, then 2 here. So if you check it out, you find out that it's balanced. But one thing that is noteworthy here, or worth noting, is that the ethanol produced is not 100% pure. So there are traces of other products. So if you want a 99.9% of ethanol, then you have to distill this ethanol produced. So distillation is another process that this ethanol produced has to go through. So after distillation, you can get up to 99.9% ethanol or alcohol. So from there, you can now get your ethanol. Again, the type of ethanol produced, or it depends on the type of starchy food that's being used. So if you want a very high product, you need to use expensive products like your beer, your grape. Those wine that we have, they use grapes and other fruits to get them so that it will be so different from others. Okay, so from here we are now going to look at the physical and chemical properties of ethanol, being a member of alkanol. So one of the physical properties of ethanol is that it is soluble in water. So we look at the physical properties of ethanol being a member of alcohol. So the first one is that solubility. It is very, very soluble in water. So ethanol is soluble in water. The reason is because of hydrogen bonds. Now, hydrogen bond is responsible for the solubility and high boiling point of ethanol. Now, ethanol boils at 78 degrees Celsius. Now, if you look at the structure, let's draw the structure of ethanol. We have a C, then you have your hydrogen bonds here, then you have your O, and you have your H. So when you place the hydrogen bonds, you have it like this. Okay. Now the molecular formula, like we know, is C2H5OH. This is the structural, this is the molecular formula. Now what is hydrogen bond? Now this is oxygen, this is hydrogen. Hydrogen bond is intermolecular bond. Intermolecular bond, that is bond between two molecules. If I have water, let's say H2O here, the structure for this should be, you have your hydrogen, you have your oxygen, and you have your hydrogen. That's 2H and 1O. Now, the hydrogen has oxygen bonded to hydrogen. This bond here is not the hydrogen bond. Hydrogen bond has to be between one molecule and another molecule. Water is a molecule. Ethanol is a molecule. So, the bond between a highly electronegative element such as oxygen, fluorine, nitrogen, oxygen, when it's bonded to any other element, that bond is referred to as hydrogen bond. So if the oxygen here is bonded to the hydrogen here, this bond is referred to as hydrogen bond. But this is not an hydrogen bond because it is within one molecule. Alright, let's stop here first.